Ladies and gentlemen, I'm Johnny Farmfield and welcome to another scene file breakdown. So someone in the Houdini artist Facebook group asked a question about doing recursive fracturing, and I immediately had this idea to do a splitting box setup just to show how simple it actually is. So let's jump in and take a look how I set this up. So of course I'm starting with the box. I'm just placing this 2 units up in Y, and I'm immediately gonna make this into a pack primitive. So create name attribute and create pack geometry, and then I'm going to create a size attribute, and this is just arbitrary name, right? So this is going to be a float and it's going to have a size of 1, and I'm going to use that as the measure of which boxes to split. Let's jump into our bullet sim. So this is really simple. I'm gonna disable this subsolver. So I have a packed object, I have gravity, and I have a ground plane. If I play this, boom, it's gonna fall down. Now to be able to show you the setup, I need to actually jump out here, and I'm just gonna simulate this. So I have a frame where it splits. Let's go back here and see. Boom. There you go. So this is frame 103, and we need to jump 1 step back because the split actually occurs on the previous frame. Let's jump into the .NET and the subsolver. So this is what comes into our .network. And first we are going to check if size is bigger than 0.05. If it is, it's gonna split into the left stream here, where I'm gonna sort the points randomly. Then I'm using a rule I created to decide if I want to split this or not. And the rule is this. It's going to be 0.0, so that's primitive 0 because pack primitives are points. The random frame is going to give me a number between 0 and 1, and that needs to be smaller than 0.25, so that's every 4th frame statistically. I also want to have the position in Y be below 0.75, and I want the frame to be bigger than 96 because I want this to fall and settle before it's split the first time. So if these conditions are all met, it's going to place it in the group split, and if not, it's not going to split it. So here we have the geometry coming in. If it's bigger than 0.05, it's going to go this way. And if the conditions are met in this split, it's going to go to the unpack. Else, it's just going to go back into the merge, and it's going to go down to the output here. It's going to go down to the last merge stop, which means it's just going to go on to the next simulation frame. But if these conditions are met, we will have a single box that will come in here, and I'm going to unpack that. So I'm going to go from having a single point being back to having 8 points because this is a cube. So this cube has sides, and I want to isolate one of these sides. So first I'm just going to sort the primitives randomly, and then I'm going to blast any side, any primitive that is not 0. So if we go back and show our primitives, primitive numbers, that's 0, and that is the one it's going to keep. Now I want to create a normal, and the normal is a vector, and the reason I want this is because in this attribute wrangle, I'm going to use the 2 first points on that primitive, and I'm going to do a cross product between them. and I'm going to use that as an op vector. Then I'm going to delete point number 1. So that is going to give me a single point. And then I'm going to move that point to the position of the packed primitive, which is the centroid of this unpacked object. And the reason I want to do this is the up vector and the normal will together give me an orient. So when I copy this splitter object, I just created this. Really simple. It's a grid with 2 transforms I merged together. That's it. But when I copy that to this point with an orient, it's actually going to orient perfectly to my cube. Whatever, doesn't matter how it's rotated. It's always going to perfectly match the orientation of this cube. And as it's copied to the center, it's going to split it in 4 equal pieces. So now I'm just going to add a normal, and then I'm going to use a for each loop to just to measure these. So what it's going to do in the connectivity, it's going to create a class attribute for each connected primitive. And for each now, I'm just going to measure the area. So I'm going to promote that from a primitive attribute to a pointer attribute. I'm just going to sum them together, and I call it size. So that is going to be used next time we check for the size when we split the boxes. And let's just assemble this, create the name attribute, create packed geometry, and we want to keep the velocity, angular velocity, and the size of these. But we also want to add some random velocity to these. So that's what I'm going to do in this attribute randomize. So both for the angular velocity and the velocity, I'm just going to add a random vector. You see I have the global scale is 5. I have the global scale of 3 for the angular velocity. That is what's going to create the boxes kind of popping when they split from each other. If I were to disable these two, they would just fall apart. So I thought this was a bit more fun. And finally, I'm going to set the ID to -1, and that is going to force the bullet solver to recalculate the collision hulls. And then we just merge this. So here we have a system that will check for size, and if the size is bigger than 0.05, it will check against the conditions. And if the conditions are met, it's going to split it and go through here. But if the size is smaller than 0.05, or if it doesn't meet the conditions, it's just going to merge back and jump to the next time step. And that is basically the whole setup. Because when we come out here, the only thing I do is I unpack the pieces, and I just make a small poly bevel, and then I merge it with basically with the ground plane. And then I just update the normals for everything. That is how you do recursive fracturing in the bullet solver. And this setup, of course, is very planned to split cubes into new cubes. But it's no problem to use this kind of setup to do recursive fracturing based on collision data or based on time or whatever. It's all about splitting the stream based on rules. So if you have an object that is a certain age, you can split it. If you have an object that has a specific force on it, you can split it. So how I did this to split these boxes into new boxes is just one example. You can use this technique to fracture anything based on any condition. So, well, I hope this breakdown was helpful. And until next time, I'm Johnny Farmfield.